Hello everyone, welcome. Today we cover section 7.2 Trigonometric integrals. So in this section we study the integrals of product of powers of trig functions. First, let me recall some useful trigonometric identities. Sine square x plus cosine square x is 1. Secant square x minus tan square x is equals to 1. Sine 2x equals to 2 sine x times cosine x. Half angle formulas. 2 sine square x equals to 1 minus cosine 2x. 2 cosine square x equals to 1 plus cosine 2x. Some indefinite trig integrals. Integrals of sine x is negative cosine x plus c. C is a constant of integrations. Integral of cosine x is sine x. Integral of tan x is natural log of secant x. Integral of cotangent x is natural log of sine x. And integral of secant x is natural log of secant x plus tan x. Let me scroll down. In these sections, we wish to answer 3 questions regarding the trigonometric integrals. The first questions: how to evaluate integral of types sine to the m power times cosine to the n power? The idea: the simplest case is when either m equals to 1 or n equals to 1. In either case, the U substitution method will work. In general, we explore 2 cases: odd power case and even power case. Say, first, if at least one power is odd. Say m is odd. M is the power of sine functions. So say m is odd. Then keep one sine factor and use the identity sine square x equals to 1 minus cosine square x. In this case, the integral is then computed by the U substitutions, where we put U equals to cosine x. Or say n is odd. N is the power of cosine x. Say n is odd, then keep one cosine factor and use the identity cosine square x equals to 1 minus sine square x. In this case, the integral is then computed by U substitutions, where we put U equals to sine x. These are the idea to solve the integrals of type in question number 1. Let me scroll down. By the way, if both powers m and n are odd, then either one of the above cases can be used. Another case: if both powers m and n are even, then either use the half angle trig identity, which is sine square x equals to, let me scroll down, sine square x equals to 1 minus cosine 2x over 2, cosine square x equals to 1 plus cosine 2x over 2, or the double angle trig identity, sine x cosine x equals to 1/2 sine 2x. Let's do a quick example. Example 1. Evaluate the integrals sine qx times cosine power 4x dx. So now here sine has power 3 and cosine has power 4. So in our formula here, m was the power for sine, n was the power for cosine. So here m is then 3 and n is 4. So here at least one is odd, the power at least one is odd, that means m is odd. So let's keep one sine factor. So let's start the solutions. Integral of sine qx times cosine 4x equals to, keep one sine factor, then the sine qx becomes sine x times sine square x. Copy the cosine to the power 4x as it is. And then we need to use the formula sine square x equals to 1 minus cosine square x. So sine x as it is, sine square x reduced to 1 minus cosine square x, and cosine to the power 4x as it is. Let me remind you on the rule. This says here, if at least one part is odd, we assume if m is odd, then keep sign factor and use identity. And now next, use a u sub where u is cosine x. Great. So let me scroll down. Then now in this integrals, now I need to put u equals to cosine x. So let's put u equals to cosine x. Then the derivative of u is du. Derivative of cosine x is negative sine x dx. Then rewrite this integrals all in terms of u variable. So this integral as it is. First, let's put cosine x equals to u. So 1 minus u square. Then u to the power 4. Then sine x times dx. Sine x times dx is negative du. I hope it makes sense to you all. So now our x integrals or our trig integrals reduces to the u variables here, u integrals. So then let me scroll down. Then here's, let's pull negative outside. Foil the u to the power 4 inside. So u to the power 4 times 1 is u to the power 4. Then u to the power 4 times negative u square is negative u to the 6 and du. Now it's easy to integrate, so just use a power rule. So negative as it is, u to the power 4 integrals becomes u to the power 5 over 5 minus as it is, integration of u to the power 6 becomes u to the power 7 over 7 plus constant of integrations c. Then reverse the substitutions. So we put u equals to cosine x, so let's reverse the substitution. U equals to cosine x, so cosine to the power 7x over 7. So what I did here, so I multiply this minus inside and write this term is a plus terms first. So this is minus, this is plus, so this terms first. Cosine to the 7x over 7 minus cosine to the power 5 over 5 plus c. Correct? Let's continue. Example 2. Evaluate the integrals sine square x times cosine to the power 4x dx. So now in this case, both of the trig function has even power. So here's m is 2, m is the power of sine, and n is the power of cosine, so n equals to 4. Then the idea says use half angle trig identity. So let's start the solution here. Integral of sine square x times cosine to the power 4x dx equals to, I break down cosine to the 4 as cosine square times cosine square, then the first term as it is, and then the sine square x cosine square x becomes sine square 2x over 4. Let me show the formula here. So here's, so sine square x cosine square x equals to 1 over 4 sine square 2x, squaring both sides. Okay, great. So let me scroll down. So this is what we got from this first term. So now from this one, I mean inside the bracket, now from cosine square x becomes 1/2 1 plus cosine 2x. Great. And then next, let's pull the constant outside. So 1/4 times 1/2 is 1/8. Integral sine as it is. Then multiply the sine square 2x inside. So sine square 2x times 1 is sine square 2x plus sine square 2x times cosine 2x is sine square 2x times cosine 2x outside dx. Great. Let me scroll down. Now this integral is the good candidate for u substitution. So for the first one, I break down using the formula. So sine square 2x becomes 1 minus cosine 4x over 2, 1/8 as it is. Then sine square 2x, we put u equals to sine 2x. Then its derivative becomes du equals to 2 times cosine 2x dx. Then rewrite this integral in terms of u. So this is u square cosine 2x dx, cosine 2x dx becomes du over 2. du over 2. Great. Now let's integrate. So pull the constant outside here. So this 2 outside. So 1 over 16. Also this 2 outside. Then integrations. Integration of 1 becomes simply x minus cosine 4x. Integral of cosine 4x becomes sine 4x over 4 plus u square becomes u cubed over 3, and u is sine 2x. So sine cubed 2x over 3 plus constant of integrations. Great. So now let's move on. Now another questions we ask to ourselves, how to evaluate our trig functions where trig function is tangent and the secant, and tangent has m power and secant has n power. Means how to evaluate integral of types tan to the power m times secant to the power n. So again, we solve these integrals in cases. So for the tangent and secant powers, we only consider the 2 special cases when m is odd and n is even. So if m is odd, means the power of tangent is odd, then keep one factor of secant x tan x and use the trig identity tan square x equals to secant square x minus 1. In this case, the integral is then computed by the u sub. Put u equals to secant x. So that's why we put secant x tan x. We keep this one because the derivative of secant x becomes secant x tan x. That's the idea. Another case, if n is even, n is the power of secant x, then keep one factor of secant square x and use the trig identity secant square x equals to 1 plus tan square x. In this case, the integral is then computed by u sub, substituting u equals to tangent x. Okay, so now let's implement this idea to evaluate this example 3. Evaluate the integrals tan to the power 5x times secant to the power 7x dx. Let's begin the solutions. Solution here, m is 5 odd. So keep one factor secant x tan x and use tan squared x equals to secant squared x minus 1. So that's the idea. So given integral tan to the power 5 times secant to the power 7 equals to integrals. So keep secant x tan x. So then how many left here? So 10 to the power 4x and secant to the power 6x. Then use this identity. So this tan to the power 4 is tan square square. So tan square becomes secant square x minus 1 and its whole square. Secant to the power 6x as it is, secant x tan x as it is, dx as it is. I hope it makes sense to you all. Let's continue. Then put, now it's a good candidate for u substitution. So let's put u equals to secant x. Then take its derivatives. U derivative is du. Derivative of secant x is secant x tan x dx. Then rewrite our this secant x tan x integral all in terms of u variable. So then this integral as it is, secant x is u, so u square minus 1 whole square. This is u to the power 6. This is everything. Secant x times tan x dx. Secant x times tan x dx is simply du. Great. Oops. Yep. So then let's FOIL this is square first, multiply by u to the 6, and then use a power rule. So integral as it is. So u square minus 1 whole square becomes u to the power 4 minus 2u square plus 1 and multiply by u to the 6, which is, after simplifying, which is this one, u to the power 10 minus 2u to the power 8 plus u to the power 6. Then take an integral here. So in the next step, u to the power 10, integral of u to the power 10 becomes u to the power 11 over 11 minus 2 as it is. U to the 8 becomes u to the power 9 over 9 plus integral of u to the 6 becomes u to the 7 over 7 plus c. C is a constant of integrations. Then resubstitute. So u equals secant x, so back u equals to secant x here. So secant to the power 11x over 11 minus 2 9th, secant to the power 9x plus secant to the power 7x over 7 plus c. Great. Now let's move on. Example 4. That's better. Evaluate an integrals 10 to the power 5x times secant to the power 4x dx. So here m is 5 odd, n is 4 even. So let me use an even case. So given integrals equals to 10 to the power 5x, I didn't do anything. Then I break down secant to the power 4 as 2, secant squared x times secant squared x. So I keep one secant squared x as it is, and I use another trig identity for secant squared x, which is 10 squared x plus 1. So that's the idea. Then this integral is a good candidate for u substitution. So let's put u equals to 10x. Then the derivative of 10x is secant squared x dx, left side is du. Then rewrite this 10 then x secant x integral in terms of u variables. Then in this next line, integral as it is, u to the power 5 parentheses u squared plus 1, and secant squared x dx is simply du. And it's again easier integrals to integrate. First foil it and take the integrals. So let's foil. U to the power 5 times u squared is u to the power 7. Integral of u to the power 7 becomes u to the power 8 over 8 plus u to the power 5 times 1 is u to the power 5. Then the integral of u to the power 5 is u to the power 6 over 6 plus c, constant integrations. Then reverse the substitutions. U is 10x, so 10 to the power 8x over 8 plus 10 to the power 6x over 6 plus c. Great. Let's move on. Now the third question that we want to answer in this section is how to compute the trig integrals with different angle of sines and cosines. That is, how to integrate the integral of type sine mx times cosine nx. M is a constant number, n is a constant number, so m can be 2, m can be pi, or n can be 9, anything. Similarly, n. Similarly, how to integrate an integral of type sine mx times sine nx. Similarly, how to integrate integral of type cosine mx times cosine nx. Here, m and n not necessarily the same. So the idea, these integrals can be computed by integration by parts. However, it's easier to use the following corresponding trig identity. If you have sine mx times cosine nx, then we use this formula. 1/2 sine mx minus nx plus cosine mx plus nx. For sine mx times sine nx, sine mx times sine nx equals to 1/2 cosine mx minus nx minus cosine mx plus nx. Similarly, cosine mx times sine nx equals to 1/2 cosine mx minus nx plus cosine mx plus nx. Great. So now let's move on. So let's do example 5. Evaluate an integral of sine 8x times cosine 5x dx. So in this example, I'm using this first formula where my m is 8, n is 5, Let me scroll down here. That's better. So then integral of sine 8x times cosine 5x equals to 1/2 from formula, and then integrals of sine mx minus nx. M is 8, n is 5, so 8x minus 5x plus, as it is, sine mx plus nx, so 8x plus 5x. I hope this makes sense to you all here. Then let's simplify it first. So 1/2 as it is, integral sine 8x minus 5x is simply sine 3x plus sine 13x. Then we can easily integrate the last integral here. So 1/2 as it is, the integral of sine 3x becomes negative cosine 3x over 3, and then there is a plus, but the integral of sine gives you minus, so this minus. Integral of sine 13x is cosine 13x over 13 plus constant of integration c. Great. Similarly, let's use another formula for sine mx sine x. For example 6, I'm using both sine sine. So keep in mind, if you have sine sine on my left side, on my right side I have both cosine cosine. Okay, great. So for example 6, evaluate the integral of sine 5x times sine x dx. Then by formula, this equals to 1/2. Then the cosine, so mx minus nx. Here m is 5, n is 1. So 5x minus 1x is 4x, minus from formula. Then cosine mx plus nx. 5x plus x is 6x dx. Then the 1/2, or maybe I integrate and then multiply through. So let's integrate first. Integration of cosine 4x becomes sine 4x over 4. 4 times 2 is 8. Great. Minus, as it is, again this 1/2 is for both. So the integral of cosine 6x is sine 6x over 6. 6 times this 2 is 12 plus c. So our final answer is 1/8 sine 4x minus 1/12 sine 6x plus c. So with that example, we finish this section 7.2. In our next class, we'll study trigonometric substitutions. This is another technique to solve an integral or to evaluate an integral. Thank you.